professor of chemistry department. He did his master's degree from this university. After this, he went to the ICB, which is a prestigious institute of chemical research, that is ICB. After that, he went to Israel and then Japan, then Canada. He is a recipient of JSPS and Canada Fellow, and he spent almost 6 years in abroad, and he is regularly publishing in some prestigious journals like JACS, tetrahedron letters, organic synthesis, organic letters, and all that. So I would request Professor Majumdar to take over the charge of this session. Professor Majumdar, please.
Thank you, Dr. Day, for your introduction. Actually, I don't know what you say. I am not at that level. Anyway, good morning to all of you. And this is the last session of this 3-day international conference. And I have seen from here, all the speakers here, all are from abroad. So this session is really the international seminar, I can say, because the speakers from Europe, Slovakia, and then another speaker from Chile, and then one from Indonesia. So this is really an international conference. At least, perhaps I know none of the session is all the speakers is from abroad. So first speaker in this session, that is the invited talk, it will be delivered by Professor Juraj Bujdak from the Department of Physical and Theoretical Chemistry, Comenius University, Bratislava, and Slovak Republic. So actually, Professor Bujdak, he obtained his PhD from the same university, and then he worked in the Slovak Academy of Sciences, and then now he is a professor of Department of Physical and Theoretical Chemistry, Faculty of Natural Sciences, and his university, Comenius University, Bratislava. And actually, if you see this, his CV, then you see he is a lot of publication, more than 100, and he is a collaborator in many international countries like Japan, Spain, Czech Republic. So he will be talking about resonance energy transfer in hybrid systems of layered nanoparticles and laser dyes. So I request Professor Bujdak, please start with.
Thank you very much. Do you hear me well? Okay, so first of all, I would like to thank organizers that I could come here. Although it was not so easy, you know, the news about the new virus, so it was quite tough. So we were not sure how we managed to come here, and if there would not be any problem. But I am happy I am here, and I can now have this talk. So my talk will be about energy transfer, but before that, I would like to say some words about our country and our travel here. You see this very small spot is Slovakia, and we had to travel through Dubai to here. Maybe Agartala is somewhere nearby the point here, showing this arrow. And Slovakia is a little bit bigger than Tripura. If you measure the area and if you count the number of people living in Slovakia, so they are quite similar countries. This is Slovakia, this yellow part here. And from Bratislava to Košice, which is a city at the edge of eastern part of Slovakia, the distance is similar from Kolkata to Agartala. So you can imagine the length of the country. There are some pictures. Castle, UFO, restaurant over the bridge. This is university, the picture of university, and this is Academy of Sciences. And Bratislava is the largest city, 500,000, and other cities are quite small. And Slovakia is full of villages and nature. Some people ask me about the weather in Slovakia. It's quite mild winter now. So in Bratislava there is no snow, but if you go to the mountains, it looks like this. We took these pictures, just several views like these ones. Okay, let's go back to the science. So, what are our topics? Mostly, recent years I'm interested in the interaction between layered silicates and dyes. You can say that what can happen if you combine layered silicate with dyes, you can just get some colored layered silicate, but it's not true in many cases. Because sometimes, not only that you can get some active layered silicate particles with active dyes, but you can change the properties of dyes. And not only this, by choosing a good layered silicate, you can properly induce the changes of the dye photoactivity or dye properties. So we have done something about light absorption, luminescence, fluorescence, metachromasia due to molecular aggregation, photochromism, resonant energy transfer, I will talk today, tuning dye properties by changing the molecular structure when they are absorbed, for example, optical anisotropy, photosensitization, or chemical stabilization or decomposition of the dyes. So this is the topic today. The motivation. Maybe you noticed who's working with dye that scientists transfer, electron transfer, and so on. And I could see one very interesting review lecture of Professor Clemensny, and she was asked about the potential application of such systems, and everybody got surprised because she said that they are so expensive to design and to synthesize, to produce, that she does not believe in potential application. So what you have in electronics, that you join transistors to some chips in this way, that if you just connect molecules of dyes to prepare some arrays which would function in many ways, she did not see any application. I believe that they will find some application, but this financial barrier to produce them is maybe not fulfilled today. So our approach is other way, much cheaper and maybe more versatile way, to prepare assembly of the dye molecules on some host, on carrier, where the substrate could concentrate different dye molecules which could interact between each other. Of course, there are some advantages and disadvantages of such approach. Advantages, you have cheap components, either dyes or layered silicates. You have a large variability of the components. You have currently thousands of dyes produced which have a very different functionality and different properties. No limit for the combinations. Simple methods. You can prepare colloidal systems, dye solution, you can modify silicate, you can do many things and combine them. Of course, there are some disadvantages. Poor control of the distribution of the molecules. If you can fix the position of the dye, maybe orientation between each other. But this is this problem. Dye aggregation. So dye-dye, particle-particle interaction. They can significantly affect photophysical properties. Type of dye would segregate on the host at different place than the other type of dye. Dye properties can change. This is sometimes advantages, as Peter Bohat showed last time in his lecture, but sometimes we observe negative effects. We use layered silicates. Why? Layered silicates represent ideal host material for us. The negative charge is because of isomorphic substitution in the structure, so it's permanent negative charge. And you can have series of the materials with different charge location, with different exchangeable cations. So you really can get from layered silicates a series of different materials. They form stable colloids, and sometimes also with single nanoparticles in the colloid. This is very important if you want to produce good hybrid materials. They can be chemically modified, and they are photophysically inactive. It does not mean that you cannot produce some other layered silicate or some other layered materials which are not photophysically inactive, but I mean, in this case, if you want just an active substrate. So, why we studied energy transfer? Energy transfer is quite important phenomenon occurring in green plants. In green plants, photons of certain wavelengths are absorbed by some chromophores, porphyrin chromophores, but the energy gained by this absorption is transferred to the sites where this energy is used for chemical reactions, for redox process. And this pathway is quite long and goes through several other chromophores by hopping, like is shown in this picture. So this inspired us if we can mimic such process by hybrid materials based on organic dyes of any kind and layered silicate. Energy transfer is very easy to observe by fluorescence spectroscopy. If you have solution, and let's say you have rhodamine dye in solution and oxazine dye, so it's mixed solution of these two dyes. If you selectively excite rhodamine dye, it will emit green light. And in solution, nothing else would happen because of large distances between dye molecules if you have dilute solution. But if you add layered silicate, what can happen? The dye molecules start to be adsorbed on the layered silicate surface, the light emission, and no green light emission. It is because of energy transfer occurring in the system. We have tested the effect of the surface concentration. Surface concentration was tested in the way that we use the same bulk concentration of both the dyes, but just change the amount of the layered silicate. Okay? So, if the concentration of the dyes was 0.5% of cation exchange capacity of layered silicate, nothing special happened. We measured time-resolved fluorescence, and we observed that the lifetime of the system was quite long, which means that there was direct emission of rhodamine 6G cations, not much affected by energy transfer. For energy transfer, you would expect much large shortening lifetime of this emission. And when we increase the absorb in the whole range of the wavelength you would like to. So energy transfer is nice way how to increase efficiency. Sensor or multifunctional materials. This is everything which can be done in future. And some special types of energy transfer, including some other phenomena such as transfer of plasmon energy, chemiluminescence energy transfer, or bioluminescence, triboluminescence, all these can be considered. In the end, I would like to thank to my colleagues, especially from Institute of Inorganic Chemistry, Academy of Sciences, who participated in such work. Then also some colleagues from Spain and from Czech Republic. And in the end, I would like to thank you for your attention. Thank you very much.
We did TRPL measurements. So lifetime of the charge carrier should be increased if it has energy is being transferred from one side to other side. So lifetime should be increased. But then TRPL showing that lifetime is decreased by lifetime is decreasing.
This was the lifetime of energy donor of rhodamine 6G. And when it is quenched, it decreases very much. maybe we measure lifetime of energy acceptor. Maybe this would increase because fast process is much faster than radiative relaxation of the molecule. So
when the photon is absorbed, the excited carriers, what we do to increase the lifetime of the...
yeah, okay. Then it has some common characteristics, such as in solutions, for example, that it slowly relaxes to the basic state by emission of light, okay? But energy transfer, as it is much faster process than if you measure lifetime, which is quenched by energy transfer to energy acceptor, is reduced significantly. Sometimes it's impossible to measure, it's so much reduced. We have not done this, but I think there are some mentions in the literature also about this.
So in case of the layered silicates and the dye molecules, pressure maybe is there?
I don't know really. I have not observed.
Thank you.
My question is related to the interaction between the dye and the silicate. How do you ensure the uniform interaction? That is first part of my question. And second part is related to have you observed any kind of dye degradation because of this continuous excitation of photons? And how far, if there is a degradation, then how far the fluorescence will remain?
Yeah.
Thank you.
We have done some studies about degradation or stabilization of the dyes. It's quite interesting that for some cyanine dyes, we observed that the degradation is reduced in solution, or at least partially. They could be stabilized in a system with layer silicate with low charge, but with high charge they were destabilized. It was quite interesting. And recently we published the paper about methylene blue. Maybe you know methylene blue bottle experiment. That you have methylene blue with glucose under basic conditions, or you have methylene blue with ascorbic acid under acidic conditions, and it changes to discolor. There are either some composites, okay, but then in the case of composites, everything is inside polymer matrix, and maybe the functionality is somewhere inside. But we consider other modification of the surfaces of polymers, and then maybe functionality is still distinct, like you can modify the surface, for example, with photosensitizer, and you can get
Energy filter. That is my type exactly.
in energy transfer,
Filtering. Energy filtering.
filtering.
Yeah.
Energy filtering.
Oh, okay. You mean filtering? Yeah, well, maybe. I don't know. You mean like to filter some light of the spectrum?
Yeah.
Okay. Yeah. If it absorbs some range of the light, I think they can be. Even with layered silicate, you can prepare some, let's say, pigments due to molecular aggregation, which are not luminescent. So, if you want, we need to distinguish. In our model, the group or the pair of rhodamine
Thank you, sir.
Hydroxypropyl methyl cellulose capped copper nanoparticles and its nanocomposite hydrogen films for antibacterial applications. These are my content. Nanoparticles. The particles having at least one dimension with less than 100 nanometer size called particles as nanoparticles. The nanoparticles are developed by different techniques, so like physical and chemical and green process. The physical techniques are little bit quite expensive because of experimental setup. And chemical process and green process are useful for utilization of applications, but biomedical application chemical process technique is not suitable because of using of toxic chemicals for reducing the metal nanoparticles. So as we know, lower size of the metal nanoparticles giving better properties for application orientation. In general, metal nanoparticles having different shapes and size. For getting required shape and size, we are using for stabilizers.
The conducting glass. So we put in the sandwich conducting glass. This is a conducting glass substrate, and then I use the ITO, indium titanium oxide, and then this is the dicot titanium oxide, and then another one is the this is a contour electrode, and this is electrode, and then conducting glass. So it will be in sandwich form. So basically in this process, it will be the reduction and oxidation reaction only. So this is the energy level, how the sensitizer has the very most important in this DSSC. So let me inform you also, the central part of DSSC device consists of a thick nanoparticle film that provides a large surface of lead for lead harvesting absorption molecules. But unfortunately, sometimes they use a dye, in the inorganic dye only. And then, why I use also DSSC? This is because of one of the low cost and easy also fabricated. If we compare with the conventional solar cell. And then here I would like to increase the power conversion efficiency, and then so that's why we have to get a good photosensitizer, and then we have to put some dopant, inorganic material dopant. So how to improve? In my research here, I use the semiconductor in these studies, titanium dioxide, which has been modified with the addition of a composite layer of the monomerilonate and the dye and also naphthalene. This study based on the some researcher, they modify also the semiconductor components and dyes like copper doped titanium dioxide, and then the dye they are using ammonium hexafluorotitanate and also hexamethylene tetramine, and then they produce 0.2% to 0.4% for PCA, and then also dope the sodium to titanium dioxide nanorods with they extracted from Kigelia africana petals, and then they have 1.09% to 1.56%. So based of this, I would like just to make a composite monomerilonate and then dye and also naphthalene. We make composites. So this is the method, preparation of dye solutions, and then preparation how ITO glass, preparation working electrode, comparative electrode fabrication and characterization DSSC using the potentiostats. So I collect this gardenia just fruits from China itself, because in Indonesia we cannot find for this fruit. And then we started by hexant, and then I get this extract, and then the color is a red one. But this color, sometimes it is depend on the pH also. If the pH less than 7, that will be a color change. And also if pH more than 7, it will be also change the color. Okay, and then this is B. So from the spectra of absorption UV-Vis, the results we get two kind of the spectrum, 3 to 9.2. So this is indicated quercetin itself, and then the other one is 436.2 and 460.6. This is crosins. So those are the dye used for increasing, for improve the PCA itself. So this is fabrication for this essay. So working electrode, comparative electrode dye, and then this is we use carbon for control, and then monmorillonate and naphthalene in between. So this is just process reactions, how sensitizer can absorb the light, and then how, and then here the electrolyte calcium iode will get process oxidize and oxidation and reduction process. So this is the result from the potentiometer. So the A, this is comparisons current density with the voltage. If you have look here, the blue one, they have the highest peak for the this potential stat curve, and then this is for the B between monmorillonate naphthalene and also the titanium oxide. After having read the data from potentiometer, so we calculate the GSC. This is the power density, VOC, fill factor, and efficiency. And then for those are the variety of the monmorillonate 0 and then naphthalene and dye. So we got the highest PCA on the 50% monmorillonate and 50% of the naphthalene. And then the last characterizations, we have done also characterization through by the AFM. So if we have a look here, this is the topography analysis of this essay, semiconductor 50% and monmorillonate and 50% of naphthalene. So if we have a look here, so the dye, this already cover all the monmorillonate and also titanium dioxide. So this is the surface semiconductors using AFM. So dilute mean square roughness value obtained is 0.22 micrometer. So this go to conclusions. The first one, dye as a potential from Gardiner has been evaluated, and then the second one is UV-Vis spectrophotometer show that peaks produce at wavelength for 406. They indicated that crossing, and then peaks at wavelength 3 to 9.2 nanometer with quercetin. And then the highest power conversion efficiency value is obtained on 0.8316%. This is with modification of semiconductors using 50% monmorillonate and also 50% of naphthalene. And then from the AFM analysis, the optimal semiconductor saw the uniform distribution of dye in the surface of roughness, which causes more dye absorbs. So, and the last one is the monmorillonate. It can be as a dopant in the DSAC. This is could increase the PCA, ethics, the theory, and everything. Because monodenoid is part of the clay or silicate, also that's almost similar. Okay, I think acknowledge would like to express our gratitude to Department of Chemistry, IPB University for lab facilities, and then Directorate of Higher Education Indonesia for funding research, and Laboratory of Physics Syahkuala Aceh for FMS chairman, and also ICMS organizer and all wonderful audiences here. Thank you very much. Bahut dhanyawad.
Now the session is open for.
So this will be different. But this now I've been doing research. I mean to continue this research because they have as Professor the photosynthesis leaves. So they have some good how to electron will be moving. Because we need the electron to absorb this.
Yes. So you write the structure of this quercetin. This is not the structure of quercetin. This is rather, I could say, crocin. The structure of quercetin is that one.
Sorry. Yes, I was thinking that this quercetin here and crocin here. They factory, and then they are using this jasmoide gardenia, and then they say they collect the color. Basically, that's a factory. There is Indian industrial from China. They will make natural color.
So this fruit is edible or this
Edible.
fruit?
In fact, due to assignment of various works in their home institutes, all invited speakers could not attend here. All already left, some already left. So we will be with those invited speakers who are still with us in this valedictory session. So this is. Now I would request Head of the Department of Physics, Tripura University, the organizing department to take charge of the dais. And at the same time I would also request the active convener of the conference to take charge. This kind of conference Department of Physics is conducting for third time here, and with the feedback from participants every year we try to update our conference. So feedback from participants, mainly from junior participants. I would appreciate the main feedbacks from junior participants with respect to this third international conference. Before that, I would request the invited speakers to suggest or to give some feedback to us so that next time, surely I appreciate the Department of Physics. I think next time means I expect that again there will be conference and department will be able to conduct this. So we require feedback from invited speakers Sir, one by one, if you give some feedback. It is easier.
Thank you everybody. I'm thankful to that organizing committee, especially Professor Hussain to invite me. And I really enjoyed this conference, and I interacted with the students and in that poster session, and poster quality was really very good, and research quality is also as per any very good institute in India. So, thank you very much.
So, first thing I want to tell all of you is that it was a very wonderful conference, and hats off to all of you, Arshad and all the other people. And what I wanted to say is that the poster quality was good, there was a lot of enthusiasm, and everything was fine. Bangla apurvo. But I just wanted to tell one thing, questions in the talks, students are not asking questions. So if something can be done regarding that, I will just request you people to ask questions. So then it will be a very good interactive session. So that's all. And I just last sentence, it is told that there is always room for improvement. But here there was no room for improvement, it was already very improved. Okay, thank you very
much. First of all, a big thanks to Professor Hashwan and his all team members, because they did a lot of work, and I have seen everything is perfect. I mean, and accommodation, food, and everywhere. I mean, they have done a great job. And if we think about science, I have seen that content of all talk is really very good. And as Madam said, a little bit questions answering is, it will be, I think it will be improved, because sometimes, students, they feel shy to ask questions, and sometimes they are also afraid to ask questions. But slowly I think it will be improved, because that attitude is not only here, it is everywhere. That problem, I personally also have felt that thing. But everything is very nice, so to me it is very perfect, nearly perfect. So next time I think it will be much more. I mean, and I hope, and this is the first time in the state to me, and also this in this this institute. So I hope the next ICMS maybe it will be held in some 2024 or something, or 2023. So thank you.
Hi, good afternoon. So for this conference, his management and personal greeting of all of us is very much appreciated. So I believe that the conference went on really well, and I interacted with a few of the students in the poster sessions. So the interaction went on really well. So, and the only suggestion which I can make is that, so if there is a session about technical characterization, because mostly this is a material science conference, the masters, first or second year PhD students. So if one or two talks are there on materials characterization, like how do we analyze data using XRD, how do we analyze anything, so that would be very much beneficial. So I request sir to find some industry experts or any other experts from the university to bring them for the next, maybe it could be in 2022 conference. So actually I should not give this suggestion in public, because there is a proverb, if there is something good, speak out loudly. And so we will make anonymous comments to him. Thank you for giving this opportunity, and I thank again Dr. Arshad for this invitation. Thank you very much.
So, congratulations to the entire team of Professor Arshad for organizing yet another very successful round. This was my second visit here, and things are getting better and better. And as one of the professors already remarked, there's little room for improvement, or there's no room for improvement essentially. Like all the technical sessions which were planned in the span of 2.5 days were kind of very well done, and like one of the things which possibly Professor Hussain could think about incorporating are some kind of poster advertisement session. So maybe a short session where students get about 2.5 minutes or 3 minutes time to do a poster advertisement, and interested students should be provided an opportunity to do that. So this is on the same lines as APS. Many times there are like 6 minutes talks, or like very short talks where the entire communication has to be done. So like 3 minutes for a poster advertisement is good time. We are doing a similar thing at IIT Patna in Research Scholars Day, where students from all the 10 departments, they come together and they advertise their work. And that gives a quick opportunity to know everyone's work at a glance, and also people in your expertise area would visit your poster for sure after that. Thank you.
First of all, I really would like to thank for the possibility to be here. I'm really honored to sit here, and it will really inspire me to work hard when I will come back to my country. I really enjoy this conference. I really enjoy very high quality talks, a lot of very nice and very high quality posters of students here. But international conferences are not just about the science, and it's also about the interaction with the people around, and this I really enjoy here too much. I really appreciate all of the students and postdocs here in the audience, and thank you very much for having a very nice time here. And my suggestion is just the continuity, and continue with this very great job here, and just use the experience you reach with every conference, and this conference will be better and better and bigger, I guess, in the future. Thank you.
First of all, I thanks to the organizer for arranging such an international conference, ICMS2020. And this is the third conference, and they have nicely managed to successfully organize this conference. And so far, I observed during the 3 days that from the different parts of the countries, different distinguished scientists, scholars, students, they have joined and shared their experiences during these conferences. And this is very unfortunate that Dr. Hussain and his team already managed to invite many international distinguished scientists, but because of the coronavirus situation or circumstances, they were unable to join. But overall, this conference is very, beautiful and very informative for the different aspects of the material science. And material science is a very broad subject, so they have nicely managed to cover all sorts of different topics of the material science, the cutting edge technologies, the science. So this is very enjoyable. Another thing is that for the students, I observed many presentations. So there are some basics, some technologies. So we need to think about the demands, everyday demands, and all those are basically embedded in the science which have been presented. So it is my suggestions to my dear students. And we are basically enriched with this beautiful conference for those who are working in material science. And everything is fine, and the food quality is very good. I think everybody, you have enjoyed this conference. I am very much happy to hear with you. I hope I will definitely come to next conferences And this conference, I've already told during my presentation that this conference is very popular among the different countries, as India and as well as different countries. So I believe in the future this conference will again be here, and we will definitely join and to share our experiences. Thank you very much. I also thank to the other departments, faculty members and students and research scholars. They have also nicely cooperated this conference to make it a grand success. Thank you very much.
Good morning, everyone. Professor Arshad and his team and the Department of Physics is putting tremendous efforts to improve the research culture of research, to develop research culture in this part of the country. This conference is a great success. I have in fact attended all 3 conferences, and every conferences it is improving. There were talks of all aspects of materials, experimental, theoretical, nanomaterials, energy materials, electronic materials, biomaterials, all aspects of materials. They were, and I'm sure every one of us has gained, every one of us improved, and this led to new interaction, friendship with other colleagues. It will lead to collaboration, and and the quality of posters. Quality of poster was wonderful. When we saw the quality of poster, it's great. I mean, all types of different aspects of materials they were taught. So let us give a big hand to Professor Arshad and his team. A wonderful conference. We know what it takes to organize a conference. It is very easy to find faults, but then for the organizer and particularly for the convener, it is always there on your mind. For about 6 months, you do not even sleep properly. So this is a great effort, and to organize a conference, particularly in a remote area like Tripura University, it is wonderful. They deserve all congratulations, and I wish them all success, and all success to future conferences. And the success of the conference is a measure. We can measure that the hall is full even on the last day. So let us thank them very much. So thank personally for inviting me, giving me the opportunity. Thank you very much.
Hello, everybody. There are 2 important aspects of science. One is obvious. Science helps to build society by understanding the laws of science and so on. But there is another very important aspect. Science is international. And because it's international, there is connection between scientists all over the world of different nations, culture and religion. And also such conferences like this helps to meet people from different countries, of different cultures, understand each other. And because of this conference, not only this time, but also last time I visited this conference, I could understand how nice people are here. I could find some friends, colleagues, and I learned something about the culture of this country. And I'm really happy because I can see the development of the research here. Professor Hussein have very nice labs with a lot of equipment, smart students, and I'm happy for this, and I will be happy to come also again if I have time and there is opportunity. Thank you very much all. Thank you.
So thank you to all invited speakers. With your to give some feedback from person can't be Nigeria. I don't know whether present here or not. Then from the
Very good experience for me to come here to Tripura University. I was thinking it is me also in guest house. I was also looking for the hotel, but they said you can stay in the guest house. So conference for me, I hope will be continue also for next year. This is also good to learn a lot of. Welcome to Indonesia, Jakarta itself. Please let me know. Okay, thank you, thank you.
She's from Nigeria.
Ah, Nigeria. Okay, madam, please, a few words. Just tell whether we are good or bad.
So, good morning, everyone. And I come from. It's my first time even hearing the name Tripura, because I know India. A lot of Nigerians, they used to come to India, but only Delhi, Mumbai, and something like that. When I heard Tripura, I say which side. So I started Googling. So purposely I came earlier. So I have to thank the convener also for accommodating me, even though I came much more earlier before the time. So it's like I'm out of schedule. But it's nice when I come. Honestly, there are so many things, and I like also the way they hold their culture. And honestly, when I come to India, I was so amazed because there are so many cultural things. Because I visited so many temples, old temples, so many palaces within Bangalore, Mysore, and Ahmedabad. I was there also. I went to Ahmedabad, not Hyderabad. Okay. So it was so nice to me, and it's a pleasure. And I like the way when you move from this side, the food is different. When you move from this side, the food is different. But when I come to here, Tripura, I feel home because I like their food the most. I never complain.
Ambedkar, Tripura University, on this organization of this international conference. I also thank all volunteers and all colleagues. They cooperate us time to time. Thank you, sir.
Any participant I would invite?
First of all, I congratulate to the organizers for successfully completed this ICMS2020, and also I thanks to the organizers for giving me an opportunity to present my research work. And yes, last 3 days successfully I enjoyed a lot, and a lot of interaction sections, poster sections, and very good informative that I collected from this conference. And also this conference is very useful to the participants for their PhD program, and also it is very, very useful to the participants, those who are guide and student point of view, both point of view, this conference is well connected. So because there are a lot of various topics covered in this material science, one should know the supervisor, the materials, what topic should be given to the student. That is very, very important. What is going on, ongoing research throughout the world. So until when we in the institute, we cannot know that, because even though if you say it's the latest right topic, for attending such type of conferences, definitely be aware of that. And also the students also do better research in their PhD program. And yes, this conference is well organized by the organizers, especially thanks to the Hussain sir, so giving me an opportunity to present a oral one. And yes, everything is well given.
At the last, you will find my abstract at the last page of the souvenir exhibition. And that also for oral presentation. So let me thank Hussain sir for giving me this opportunity. Secondly, the conference, it was scientifically so blessed actually. It was so strong actually. It helped me a lot actually. So though the place is very dry, actually the university campus, so I request the authorities to grow some plants over here actually. But the people over here I met, whoever, they are very friendly. Thank you so much.
Yeah.
So, if there is no way, I close this item. I close this item, and now I will request convener to conduct this award presentation with respect to presentation of paper.
Patience throughout the 3 days, Sir is my teacher, and once he told me that if someone has sleeping problem, you attend a conference and it is beyond your topic related research, then you will feel asleep inside. Whenever you go out, I was pushing you inside, go inside. So I am sorry for that. I was no alternative options. Okay, anyway, so there was one keynote talk, 19 invited talk, 21 oral presentations, and 146 poster presentations, and more than 200 participants, including sponsored by Royal Society of Chemistry, and also one award by the organizers. And before that, I want to give a small announcement that we are publishing the full paper related to your presentations in one of the Elsevier journal, Materials to the Proceedings. Already more than 30 papers we have received through Elsevier online submission systems. So if someone of you interested, then you can submit your full paper by 21st April. This is the last date. Okay. So you can go through the conference website. Details guideline is given there. 3 RSC journal, soft matter, biomaterial science, and polymer chemistry. They are giving 3 awards each for poster presentations, and the awards consist 1 year free subscriptions of the RSC journals plus a certificate. So I am just telling the name, and you can come over here and collect the awards. First, I will tell the 9 names one by one, and then you please come one by one. A.M. Das, Guwahati University, 01 ACMD. Are you present? Please come. Next, you please be ready. Apurva Sinha, IIT Patna. MS Murari, Mangalore University. Present? Maybe absent. Then Ramgopal, IIT Dhanbad. Next one, please be ready. Dipankar Das, Tripura University. Shubhajit Kundu, University of Calcutta. Sukanto Riyan, Tripura University. Mayuri Malwade. Then Bijoy Krishna Das, Tripura University. So this. So next we have Best Young Scientist Award given by RSC Journal RSC Advances. The award consists of cash award of 5,000 rupees, a certificate, and the winner is Sneha S. Rao. Best Young Scientist Award goes to Sneha. Next, Best Oral Presentation Award by the organizer, and the award consists of a cash award of 3,000 rupees, a certificate, and a memento. Somarjit Sharma from Guwahati University. Maybe absent. Anyone from Guwahati University? On the 9 poster presented, best poster with me, your email ID and a name and address. Then they will give you the ID and password for journal access. Okay, so you send me mail. Okay, thank you very much.
Last, like within this small time, full-fledged feedback. I would request all participants, still you are free to give any feedback to the email address of our coordinator. So feedback process will be continued for some days to the email address. Any kind of suggestion you can give. And with respect to this conference, first I would give my thanks. Of course, first thanks I give to the Department of Physics itself. Because if we compare this department with respect to departments around the country, it is a very small department consisting of 6 minus 1 equal to 5 teachers. Minus 1 myself. 5 teachers are running this department, very tough. Sometimes for theoretical purpose, I would acknowledge various institutes and universities of our countries. In fact, from 1990 to 2000, it was very tough. Only 3 teachers. We were inviting teachers from outside institutes and we had done it. But after I have got the junior teachers, of course at that time our head of the department was very small and junior, and Arshad, Anirban, Ratan, all young teachers, I find so much enthusiastic and so much supporting to the department. I need not express this because I feel it is my proud that I have got them. And with this, the department has come forward to organize several international conferences, including this and other kind of faculty development program, like refresher course, 2 refresher courses conducted, and some experimental workshop was conducted. Anyway, so I need not say about my department, but I need to mention the sister concern of my department, the sister department, Department of Chemistry. Department of Chemistry always extending their hand to the Department of Physics regarding this organization of various programs. Not only various programs, they also come forward with various academic activity of the Physics Department. So my thanks to the Department of Chemistry, mainly to Dr. Utpal De and Dr. Shaman Majumdar. And I also mention Department of Molecular Biology and Bioinformatics. Dr. Surajit Bhattacharya giving his complete cooperation to the department, and I found a nice paper was published from his biology department to this material science conference. And I thank to all invited speakers. So your presence is nothing but an inspiration to the department. Of course, academically, and when our scholars finds you bodily, physically present here, they are always inspired with respect to your presence. So again, I thanks to all of you and your presence. And now I appreciate the participation of many young scientists, because to me, young scientists are the future of the country. Past, present, and future. Future, they are the, in fact, poster session, I found a lot of scholars are nicely presenting their work to the various questionnaires, and all aspects of material have been covered, as sir told here, with respect to this conference. And again, I would appreciate the participation of these young scientists and young scholars. Also, I would thanks to the departmental scholars and students for their active participation in organizing the program. With this, in fact, how to finish something while giving thanks to the, I don't know. I can just tell a single line from Tagore that Shesh nahi je, Shesh kotha ke bolte. Just Shesh nahi, where there is no end. Who will give the finishing word? No finishing word. So, we can tell another line is that Patang tar pakhaye pelo khonotare chhando pure giye miliye gelo sei tari anando. We come here, we do work, we publish paper, and there will be time when we will be nowhere here. This is the line from Tagore. Anyway, sir, my respect to all senior teachers, all country-wise scientists, my pranam to all of you, and my blessings to all.
After this, I request all of you to go to the guest house for lunch. We will be there, and bus will start in front of the guest house sharply at 1:45. So please be in the bus on time, so that we can come back again on time.